These are the video notes for the 2.1 work check. And in this work check, we're going to be looking over your do now from today, and we're also going to look at the classwork that you did yesterday too, to make sure that you're on the right track. So from today's warm-up, the 2.1b, discrete and continuous functions, part 2. So the first couple of problems we're asking you to calculate the rate of change. To do that, all you have to do is divide the total distance by the total time for each problem. And so for example, if you travel 240 miles in 3 hours, you just divide those two numbers, then you'll get 80 miles per hour. Do the same thing for the Mercedes-Benz, 150 miles in 2 hours, and you'll get 75 miles per hour. So between those two rates, the BMW is fastest, so it has the greater rate of change. For the Chase and Amiens examples, Chase spends $84 in 7 days, so you divide those two numbers and you get $12 a day. Amiens is $42 in 3 days, so divide those two numbers and you get $14 a day. Between those two rates, Amiens spends more dollars per day. For number 7, it was a little bit trickier because it tells you that Mauricio runs 8 miles in an hour and Maya runs 2 miles in 13 minutes. So one has hours and one has minutes. So you can think of this as Mauricio's rate as 8 miles in 1 hour, so that's 8 miles in 60 minutes. And you can divide those two numbers, and so you get that he runs 0.13 miles every minute. And then Maya is 2 miles in 13 minutes, divide those two numbers, so you get 0.15 miles per minute. So she runs a couple more miles per minute than Mauricio, so she has the greater rate of change. For the graph on the bottom, between Leftville and Wrightstown, you can see in the same period of time, Leftville only goes up about this much, whereas Wrightsville starts here and then ends here, so it goes up that much over the same period of time. So Wrightsville has a greater increase in population over the same period of time, so it has a greater rate of change. So that would be Wrightsville. Now I'm going to switch over. And you can go ahead and put this warm-up away and take out yesterday's, or flip to yesterday's classwork. So it should be the 2.1 classwork supplement. 2.1 classwork supplement, and we'll check your work that you did for these problems. So for the first one, it's telling you that she starts with 5 pennies, which is here, and then each day she's getting 3 more pennies, so we know that we're adding 3 pennies every single time. And then so for our graph, it should look something like this, and we're not going to connect the dots. Our recursive function is each term is equal to the previous term plus 3. We started at 8 on the first term. Our explicit function is our common difference, which is 3 times the number of days, and we started with 5, so 3n plus 5. This is going to be a discrete function. And it's discrete because she receives the pennies all at once on each day. So between day 1 and day 2, for example, she's not receiving any more pennies. She only receives the 3 pennies, the 3 new pennies all at once on day 2. So we don't draw a line between 1 and 2. Between day 2 and day 3, she doesn't receive any new pennies until she gets all 3 at once on the new day. So we don't draw a line between 2 and 3. The change happens all at once. It's discrete. Don't connect the line. For number 2, you start with 5 gallons in the pool. That's where this 5 is from. Right here. And then every minute, 2 gallons are filled. So that means your common difference is it's going up by 2 every time. So your graph is going to look like this, starting at 5 and then going up 2 every time. our recursive function. Each term is equal to the previous term plus 2, and we started at 7 after the first minute. Explicit function, it's going up by 2 every minute plus 5. And these are all n's. I wrote n's because I'm so used to it, but I realize now it's actually supposed to be t. So you can, if you have t for these n's, that's actually the best way to write it. And this is going to be a continuous function, so I do connect the lines. And it's continuous because between each of these minutes, the water continues to flow and it continues to fill the pool. So the water level is gradually increasing. It's not that the water all comes in at once, right at each minute. So continuous because it gradually fills. And so we connect the lines. And yep, that's all you were supposed to do yesterday. And so now, after you are done checking your work on these problems, your group work today is going to be to do problems 3 and 4, and then don't forget when you're done with 3 and 4, go back into your module workbook to page 3, and then you're going to answer problems 5 through 7.